Good day, my dear students. We have come together again. Today, we are continuing our coordinate geometry. Specific objective. Okay, we have objectives here. At the end of the lesson, the students should be able to identify different forms of equations of straight line. Then find the equation of a straight line giving some points and possibly the gradient. Determination of equation of a straight line. In general, straight lines can be represented by any of the following equations. You can see the first equation, the second equation, the third one, and the fourth one. Each of them is the equation of a straight line, and you will understand each of them better as we go on. The first one is called the gradient intercept formula. We say, given any straight line graph with vertical intercept C, we can develop the equation of the line as follows. Look at this diagram. So using triangle UMV, this is an angle theta. It is also the angle theta here since we are continuing with a single straight line PQ. The tangent of the angle is giving us UV all over MV, giving us opposite over adjacent. So from here we can see that UV is equal to MV tan theta. For some of you, you will say cross multiplying. Okay, note please, we have observed that UV is equal to MV tan theta. We shall work with it. We say from that same diagram, I repeated it here, that UW is equal to UV plus VW. Look at it, from U to W is equal to from U to V plus from V to W. But already we have seen that UV is giving us MV tan theta, then plus VW. What is VW? VW is from here to here, which is also equal to from 0 to M. So from 0 to M is M minus 0, which is equal to M. So I will now use M to represent VW. Already, MV, look at MV, from M to V, assuming X is standing here, is also equal to from this 0 to this W where X is, now becomes X minus 0 to give us X. As a result, MV tan theta now becomes X tan theta, while VW is simply M. Now, UW from here to here, which means if you go from U across here, Y is standing somewhere here, not this Y. Y here is the axis, but there's another Y here which I'm supposed to put, but you should understand it from here. From that place down to the point we are, from that place down to 0, what is your problem, is actually Y minus 0, which is actually Y. So we shall use Y to represent UW, and tan theta I have already told you that the tangent of the angle which a straight line makes with the positive x-axis is the gradient of the line. So A here means gradient, which is representing tan theta, and M is the point where the graph cut the y-axis. It is actually called the intercept. An intercept in a straight line equation is usually represented by C. But that does not mean that wherever you see C in an equation that it represents intercept. Here we shall be using C to mean the intercept. Ya is the gradient, X is a point on x-axis, Y is a point on y-axis. So when we open the brackets, we get Y to be equal to AX plus C. This formula is what we call the gradient intercept formula. We carry on. Example, It says find the equation of a straight line with gradient A equal to 1.5 and the vertical intercept C equal to 3. Solution, you have to draw the line. Can you see it? I've drawn the line here. Given A to be equal to 1.5 and C to be equal to 3, we state the gradient intercept formula as is given before, and then put in the values. A is equal to 1.5, put it. C is equal to 3, put it. This is actually the equation. But if you don't want to work with fraction, you can multiply everywhere by 2. Actually, this 1.5 is known to be 3 over 2. So in order to make sure there's no fraction, you can multiply everything by 2 to get 2y is equal to 3x plus 6. If you want x to come over here, you simply subtract 3x from both sides to get 2y minus 3x is equal to 6. Next, another form of equation of a straight line is the one we call the double intercept form. So, what does it mean to say the intercept is double? It means that when the line cuts across both the y-axis and the x-axis, it marks off points from 0 to A and from 0 to B. So there is an intercept on y-axis, there is also another intercept on x-axis, giving rise to what we call the double intercept. So we say, using similar triangle, from O to A, that is from here to here, which is 0 to A, we represent it by the small letter A, and from O to 0 to B, we represent it by small letter b. And we have that. Look at it, mn over OA, this mouse, you have to be respecting yourself. Mn over AO, look at it, this over this is equal to this over this. That's what we mean. As a result, is equal to Bn over Bo. We come down, remember that Bn is from here to here is called Bn. It is a whole of this length minus from here to here. That's why we are saying Bo minus On. We come down. Mn, which is from M to N, is representing y, reason being that at this particular point we have the coordinates x, y. Okay, actually this x is not supposed to be here but here. So as a result, what do we have? Y over A, reason being that Mn from here to here is the y interval, represented by this y, and OA, which is from here to here, we have told you we represented it by A, so we write y over A. Again, from O to B is represented by small letter b, which I have written here, and what do we have? From here to here, okay, that one is correct. From O to N is represented by x because x is somewhere here. Look at it, x. So it is written x. All over BO. BO is from here to here, which is over B. Then we work with y over A to be equal to b minus x all over b. If you understand what we are doing, then we continue moving. We can separate the fraction here in partial form. Remember, this will read b over b minus x over b. I go ahead to see it. That y over a becomes b over b minus x over b. For b over b is equal to 1. We still have x over b. As a result, if we add x over b to both sides, we shall get y over a plus x over b to be equal to 1. Remember, I may decide to write x over b before y over a on this side, which still remains correct. Now, what do? We take the LCM of b and a to be equal to ab, and after division and multiplying, we shall get ax plus by all over ab to be equal to 1. But when you multiply both sides by ab, what are you going to get? You'll be getting ax plus by to be equal to ab. Then subtracting ab from both sides, we will get ax plus by minus ab to be equal to 0. Actually, we have already shown somewhere that minus ab is equal to c. But even if it is not shown, we shall decide that minus ab should be a constant in the system, which is represented by c. Forget that I wrote plus there. This plus does not necessarily mean that c is positive. C can be negative. So that plus minus will still remain minus. Then we continue. Example. He said, find the equation of the line given below. We have been given this straight line that passes through the point y is equal to 3 and x is equal to 4, and we have to find the equation. So we simply state the equation of the two intercept line, meaning state the double intercept form of the equation, which we have stated here. We note that a is 3, b is 4, and c is minus ab. Remember, 3 multiplying 4 is 12, but the negative of it should be minus 12. Then, stating the equation and putting in values, we shall get 3x plus 4y plus minus 12 to be equal to 0. Upon evaluation, we get our equation to be 3x plus 4y to be equal to 12. Whatever you see here, write it down, try it yourself, and see how good it will be. You will not get it right without doing it, so please always do what you see me do here. And even to check where I am correct and where I am wrong, wherever you find error, please let me know so that we'll put it in order. Next, gradient and 1.4. Okay, if the gradient A and 1 point P defining represented by x1, y1 on a straight line are given, the equation is obtained as follows. You can see there is a straight line drawn here. This Q is an arbitrary point, any point on the straight line, it can be anywhere, represented by xy, but P is a defined point on the straight line, represented by x1, y1. That's the point we are talking about. Assuming we are given the gradient, the slope, which is the gradient of the straight line, must always be change in y-axis over change in x-axis, which is y minus y1 over x minus x1, as is stated here. So what do? This A is simply A over 1. By your cross multiplication, as you used to say, 1 multiplying y minus 1 will give you y minus 1 is equal to A multiplying this will give us A into x minus 1. This formula is what we call the gradient and 1 point form of a straight line equation. Can we use it to solve any problem? Of course we can. Let's go ahead to check if there is anything like that. Example, it's a find the equation of the line with gradient A equal to 5 and which passes through the point where x is 3 and y is 7. You can see it. We have drawn it. It has passed through the point P where x is 1 and y is 7. It means x1 is 3 and y1 is 7. So we write the slope A is equal to 5 and x1, y1 is equal to 3, 7. So we state the equation as is given to us before and put in values. Remember I have said y1 is 7 and x1 is 3. While this x remains as it is, the gradient, which is the slope, is given as 5. Once you put in the values, open brackets and collect terms as much as you can. When we open these brackets, remember 5 multiplying x is 5x, and 5 multiplying minus 3 is minus 15. So, what do? We can try to assemble everything by subtracting 5x from both sides and adding 15 to both sides. What we get at the end, the equation now results in y minus 5x plus 8 to be equal to 0. From here, I know you can do it very well. Handle it carefully to know why we got this. Always remember to let us know if you find anything funny or anything you don't understand, you let us know. Next, another form of the equation of a straight line is what we call the 2-point form. We say if two different points are given on a straight line, the equation of such line can still be obtained or generated from the fact that the gradient of a straight line is uniform throughout the whole length. Hence, given the gradient and other 2 points on the line, the equation can be obtained. Even without the gradient, once we are given 2 other points, we can generate the equation. So let's go on and see what will happen. Here, we have the straight line with the 2 points, x1, y1, and x2, y2. We just decided to choose the points xy as an arbitrary point, which is any point on the straight line, and we want to take the slope. Remember, since this particular line is a straight line, the gradient is uniform everywhere, as we said before. So the gradient from here to here is equal to the gradient from here to here. As a result of that, we say that change in y over change in x remains constant. Y minus y1 over x minus x1. What's wrong with you? Y minus y1 over x minus x1 is still equal to y2 minus y1 over x2 minus x1. This is even okay. But if you care, you can decide to let y minus y1 stand alone by multiplying both sides by x minus x1. If you do that, what you are going to get is y minus y1 to be equal to y2 minus y1 over x2 minus x1, which stands as the gradient, then multiplying x minus x1. So the last thing we are seeing there is the equation of a straight line giving 2 points x1, y1, and x2, y2. So you must not be given the gradient before you generate the equation of such line. Once 2 points are given, you are done. We take an example. It's a find the equation of the line that passes through the points where x is minus 2 and y is 5, and another point where x is 4 and y is 2. Solution, what we do? Choose any arbitrary points x, y to be on the line. Then, from the general equation, which we have known, what we have? Draw the line. You can see the line, the points where x is minus 2 and y is 5, and the point where x is 4 and y is 2. We state the equation and put in values. x1, this is, if we call this 1, we call this 2. If we call this 1, we call this 2. Either of the two can be 1 or 2. The first point and the second point, I mean. So the first one must not be written first, and the second one must not be written last. You can write it the way you like, but the only thing is that the order must be followed. If you start x1 here, y1 must also start here. If you start x1 here, y1 must start here. So we get it, putting in values, we call this y1 5. So y minus 5 is equal to 2, which is y2 minus 5 over 4 minus 2 into x minus 2. Evaluate the system. Remember that minus written together will result into plus, which is the reason why we have what we have here. Upon evaluation, we get this, and open all brackets to get 6y minus 30 to be equal to minus 3x minus 6. Then connect all variables to the left-hand side and all constants to the right-hand side, and divide through by 3 to get 2y plus x to be equal to 8. Please, whatever we are doing here, you are also the one doing it. Don't just read through what I am doing or watch through what I am doing. As you are doing it, you should be writing it down and doing your work. When you are done, check how many of the assignments you have done and how many of them you have done well. I checked your Google Classroom and I observed that very few of you did the assignment as submitted. Please do the work that is being given to you. Thank you, my dear students. God bless you.